Mistakes come in all shapes and sizes. When it comes to mistakes in construction, these can come at great expense, be that expense human lives or simply monetary. Of course, sometimes the only cost of these mistakes is the pride of people who simply should have known better. But whether they were simple oversights or catastrophic failures that were easily foreseeable, today we're going to look at some of the worst and truly most bizarre construction mistakes ever made. This mistake wasn't nearly as devastating as some of the others that we're going to be talking about today, but it is still an entertaining story simply because of where it happens. The Massachusetts Institute of Technology is considered one of the best schools in the world, and it's certainly a place where one might expect people to know a thing or two about engineering. The Green Building was even designed by famous architect I.M. Pye, who was himself a graduate of MIT and who had studied engineering at the school as well as architecture, though he only completed an architecture degree. However, when it comes to the initial architectural design for a building, style and form take precedence over practicality. It certainly didn't help things that the entire basis for the design of the Green Building was to circumvent the law via a technicality. MIT wanted the Green Building to be the tallest building in Cambridge, but they couldn't just build it as tall as they wanted. A city ordinance limited the number of floors. The maximum number of floors a building was to have was 18 or 19 if the ground floor was just lobbies. To get around this restriction, the ground floor of the Green Building was 30 feet tall. Essentially, the building was put on 30-foot stilts, and the ground floor was a mostly open area with no exterior walls. There were two enclosed lobbies beneath the building, one leading to a set of elevators and one leading to a staircase that would take students to the lecture hall on the first floor. It seemed like a clever workaround, and from 1964, when construction was completed, until 2019, it remained the tallest building in Cambridge. The record was broken by another building at MIT. But although they succeeded in making the city's tallest building, there was a major problem with the design. The Green Building was surrounded on three sides by other MIT buildings which were shorter and much longer. The fourth side, which was the one the students would enter or exit from, faced a large open area leading directly to the Charles River. Because of the arrangement of the buildings and the high winds that often came off the river, this created a powerful wind tunnel. Wind would build up on the walls of the Green Building, and there would be nowhere for it to go except down into the open ground floor. The winds that gathered beneath the building were so strong that the lobby doors would become nearly impossible to open. Sometimes the winds would get so strong that students had trouble even walking to the doors, not that they would open to let anybody in and out anyway. Fortunately, the building was connected to adjacent campus buildings through underground tunnels, so nobody was ever truly trapped inside the Green Building. But it is still the sort of thing that you might expect a bunch of people from MIT to have been able to identify as a problem ahead of time. Eventually, the hinged lobby doors were replaced by revolving doors that were less likely to become impassable due to high winds. There's a long-standing myth that a sculpture called the Big Sail was installed in front of the building to deflect the wind so the doors would open, but this isn't the case. The sculpture is just there because MIT likes putting art on their campus, and it is far too far away from the entrances to have any meaningful impact on the intense wind tunnel beneath the Green Building. King Gustavus Adolphus is considered one of Sweden's most successful wartime rulers. However, during the 1620s, there were some setbacks. Sweden was engaged in naval wars on multiple fronts and experienced some serious losses. In 1625, a squadron of 10 ships were all run aground and destroyed, and in 1627, two of Sweden's large warships were lost during a battle as part of the war against Poland-Lithuania. The king wanted to send a message and take back control of the seas, and he wanted to do it immediately. To do so, he ordered the construction of a massive warship with lots of heavy guns to be built as quickly as possible. The prevailing tactic at the time was to achieve victory by boarding enemy ships, but Gustavus Adolphus believed in the power of artillery, both for sinking enemy ships and for demoralizing the opposition by demonstrating the raw firepower of their military. To that end, he ordered the construction of the Vasa, a ship that he wanted fitted with 72 24-pound guns. Although Vasa was going to be neither the largest ship in the world nor the one with the most guns, this was still a huge statement and a massive departure from the ships the Swedish Navy had previously used. To start, it would be their first ship using 24-pound guns instead of 12-pound guns. It was also going to be their first warship with 2 gun decks, as 72 guns was too many to fit on a single deck. During construction, the number of guns was lowered to 56 because they were unable to source enough guns. Now, because this was not going to be the largest ship ever built, in many ways it was a rather ordinary construction job. It appears to have been deemed so routine that there weren't any written plans or design sketches for the ship, just the specifications ordered by the king, which changed at least once after construction had already begun. However, while the shipbuilders treated this job like the ones they were accustomed to, the 2 decks of guns were much heavier than what the builders were used to. This created a major problem. The ship was extremely top-heavy. The typical solution here would have been to ballast the ship by adding more weight to the bottom, but this wasn't possible for a couple of reasons. To start, there wasn't really anywhere left to add additional weight, but even if there had been, it would have presented a major problem. A floating object displaces a volume of water equal to its mass. If more weight was added to the ship, it would need to displace more water, meaning that more of the hull would be submerged. Unfortunately, in the case of the Vasa, this would have left the first deck of gun ports underwater, rendering them useless, obviously. In the summer of 1628, construction of the vessel had been completed. The captain of the ship ran a stability test for the vice admiral by having 30 men run back and forth across the deck of the ship. The vice admiral stopped the test after the men had only run 3 laps because it seemed obvious that the ship was about to capsize. But for some reason, its maiden voyage was not called off. August 10th was a calm and sunny day with barely a breeze. A crowd of hundreds or possibly thousands gathered in Stockholm to watch Vasa, their nation's new extravagant warship, begin her maiden voyage. And just minutes later, they would also see her sink. The ship had traveled just 1,300 meters, less than 20 lengths of the ship itself, when the sails suddenly caught a slight breeze. The gust is believed to have only been 8 knots, that's just over 9 miles per hour, but it was enough to make the boat heel. The gun ports had been opened to fire a salute as the ship left Stockholm, and when the ship heeled, the gun ports fell below the waterline, causing the ship to take on water. Vasa had been unstable to begin with, but with this additional weight, the ship was simply unable to right itself. It quickly sank the 30 meters to the bottom of the harbor, though the ship was 50 meters tall, so surviving crew were able to cling to the upper masts that were protruding from the water. Unfortunately, not all the crew was able to escape. About 30 sailors who were below deck when the ship began to go down were lost. The ship's captain, narrowly escaping drowning, was ultimately arrested and interrogated. In the end, no charges were filed against any of the crew or builders of the ship. But on the bright side, the protruding masts made the shipwreck easy to find, so they were able to salvage the heavy and expensive bronze cannons from the ship. The collapse of Block 7 at Lotus Riverside is one of the most unique disasters ever seen. The building was one of 11 identical 13-story buildings in the apartment complex that had nearly finished construction. And at about 5:30 a.m. on June the 27th, 2009, it toppled over. The building collapsed onto its side while remaining almost completely intact. Even some of the windows remained unbroken after the fall. It was a disaster, to be sure, but it could have been a lot worse. The building narrowly avoided colliding into an adjacent building in the complex, which could have potentially caused several of the apartment buildings to collapse like dominoes. Although the apartments had mostly been sold already because construction wasn't quite complete, it was not yet full of residents. Most of the workers were able to escape in time, though migrant worker Xiao De-kun did not, and became the collapse's sole fatality. For the most part, the mistakes made during the construction of this complex were fairly routine symptoms of greed. The apartments were built using substandard materials and unskilled workers in an attempt to erect them as quickly as possible. It wasn't in compliance with China's standards for construction, and lots of money had been embezzled by the 2 main shareholders of the project, both of whom received life in prison following the incidents, and it was just generally considered to be a building that was shoddily assembled. This all explains why the building might collapse in general, but what could have caused it to topple over in one piece the way that it did? While there is some dispute over the cause, particularly because only one of the buildings fell over, there is a generally accepted theory for how this could have happened. Construction of a garage was taking place beneath the building, requiring massive amounts of earth to be moved from under the building to somewhere else. That somewhere else was directly next to a creek running alongside the apartments, and it is believed that the weight of this additional earth caused the riverbank to collapse. This then caused the water to seep into the ground, weakening the foundation and causing Block 7 to fall onto its side. But there was a silver lining to all of this. No sooner had the dust settled from this disaster than Chinese companies began offering tours of the location, allowing tourists in China to visit the famous apartment building that was resting fully intact on its side. The Sydney Opera House is one of the most iconic landmarks in Australia, and in 2007 it became a UNESCO World Heritage Site. However, its construction was destined to be a failure from the outset, primarily because of how the design was selected. Rather than having the Sydney Opera House Executive Committee hire an architect who they would work alongside, instead the design for the Opera House was chosen through an international competition. There were 233 designs submitted, and judges immediately fell in love with a design submitted by Danish architect Jorn Utzon. However, there were a few problems with this process. To start, competitors were asked to submit designs without being given any parameters within which to work. There was no defined budget or timeline for the construction, so they were free to submit as ambitious a design as they wanted. Far more crucially, the judges didn't seem to take practicality into account in their decision-making process at all. Utzon's design may have been beautiful and somewhat revolutionary, but it was also incomplete. He was upfront about the fact that he hadn't finished the structural design, meaning that he wasn't sure how all of this was going to be built without collapsing in on itself. But despite having little more than a few sketches and a dream, the executive committee insisted that construction begin immediately. This created numerous problems, most notably with regards to estimating the budget and the length of the project. It was initially estimated that the Sydney Opera House would take 4 years and $7 million Australian dollars to construct, but this seems to have been just the committee's default estimate. Since there wasn't even a complete design for the structure, there was no way to truly gauge how much it would cost or how long it would take. There also wasn't anybody who was actually in charge of the project. Utzon was there to watch his vision come to life, but there was also design engineer Ove Arup, who was hired to ensure they constructed a functional building that wouldn't collapse under its own weight. Unfortunately, neither Utzon nor Arup was officially the project manager. They were instead meant to act as partners, but with one focusing on aesthetics and the other on practicality and logistics. This led to a lot of confusion and conflicting orders. In 1966, 7 years into what was originally thought would be a 4-year project, the construction hit another hurdle. Following a dispute over payments and the committee's refusal to let Utzon use the specific plywood manufacturer that he wanted, Utzon resigned from the project. He took all of his design plans with him and left Australia, vowing never to return. He died in 2008, having never seen the completed Opera House. With Utzon and his plans gone, Arup and the remaining workers had to redesign the partially completed structure. The redesign made costs balloon, and by the time the Sydney Opera House was completed in 1973, it had taken 14 years and 102 million Australian dollars to complete. But the results spoke for themselves. The Sydney Opera House was beautiful, iconic, and famous for having absolutely horrible acoustics. The construction was designed with visuals in mind rather than acoustics, which is a pretty big mistake when a venue is for live music performances. Not only do the high, narrow shelves, which the Opera House is famous, create an inconsistent acoustic experience for the audience, but it is extremely difficult for musicians on stage to hear one another. In the decades since it opened, over $300 million has been spent on renovations to try and improve the Opera House's sound quality. But I mean, hey, at least it looks cool, right?